Now, this lecture segment looks at the reasons that macros are very common in C code, and the relationship between macros and an important modern language feature. Macros are an early example of what in a modern language would be an inline function. We'll look at how to mimic inline functions with macros, including avoiding the call by name problems we saw in the prior segment. So starting with a fresh slate in the diagram here, why do we want macros in the first place? Given the design complexities, why use them instead of functions? I mean, wouldn't a min function be better than a min macro in all respects? Certainly we wouldn't have to worry about side effects in call by name parameters, writing obsessive parentheses, giving odd names to locals. So, question 1. This is something you can reason out for yourself if you think carefully about prior lectures on the RTS and what it takes to do a function call to min. Well, that's the one big advantage for the macro. We're back from a pause. The major advantage is speed. With macro substitution, there's no stack frame to create and initialize, no parameter list to copy, no jump to the function, no return value to copy, no stack frame to destroy after the return, etc. Especially if the actual code is small, as in min for instance, a macro can be more than 10 times faster than a function call. Of course, you do have the space inefficiency of substituting the same macro code over and over into the caller every time it's used. For a sizable macro, this can result in larger executable sizes, but in the right case, the larger executable is worth it for the speed. And recall from earlier lectures that a function call is not exactly a small bit of code either. It's easy to think that a one-line function call would have the same executable size as any other statement, but as the lecturer on RTS explained, a function call translates into the equivalent of several lines of standard source, with all the register saving, stack frame building, parameter copying, etc. So a small macro like min may actually yield smaller executable sizes than an equivalent function call, despite the repetition of substituted code. The speed of code substitution versus standard functions is more than a curiosity. It's a central design issue in the engineering of large software systems and in programming languages. C's macros are an early and admittedly primitive example of what in modern languages would be an inline function. Almost every modern compiled language offers a means by which one may designate an otherwise standard function to be inline, meaning that calls to the function will be carried out by substitution of the function's code directly into that of the caller, like C macros. In many languages, the syntax for this is simply to add an inline keyword to the function header, with no other alteration of the function code. And inline functions, despite working by code substitution, do not suffer from call by name problems. They work just as normal functions would. So here's an exercise to see how a compiler might accomplish this. Try rewriting the strcpy function I just popped up here on the diagram as a macro without changing the basic design of its loop, and make it immune to call by name problems. Consider making temporary copies of the parameters. This is what a compiler does to inline functions to prevent call by name problems. Here is one possible answer. This code evaluates each parameter exactly once, in parentheses to avoid operand stealing, and stores the results in block local variables with almost certainly unique names, and then uses the block local variables in lieu of the parameters. This avoids call by name problems. Now, your answer may have different variable names, but to be correct, it needs the same basic pattern of one-time evaluation of parameters and storage in block local variables with unusual names, and then use of the variables instead of the parameters. Now, sadly, there's no way to return a value from a code block macro. So code block macros can only mimic inline void functions. Expression macros can imitate inline functions with return values, but they can't run loops or other complex code, nor declare helper local variables to avoid call by name problems. Some C compilers actually add a special feature allowing a code block to return a value, so that you can get code block macros to imitate any kind of inline function. And of course, a compiler that was offering function inlining would use something similar in its internal machine language translations of inline function calls. So, question 3. Look up the syntax for returning a value from a code block in the GCC compiler. Use this to rewrite the min macro to return the min value of its parameters, but without pass-by-name problems. Assume the macro should work only on integer values. And coming back from a pause there, here's one reasonable answer. What this does, this one possible answer at least, is put the block in parentheses. And that's not standard C syntax, right? That's special to GCC. That makes the block into an expression. And the value of the block expression is whatever the last expression within it was. It's effectively like a return almost, though you don't write return. And this would then be a fully functioning min macro that avoids call by name problems, provided, of course, you're working in GCC. Now, one of the languages that provides inline functions, the more modern approach, is C itself in its C99 version. The standard ANSI C offers no inline functions, only the old macros, but almost all C compilers now meet the C99 standard, and you can pretty safely use its inline keyword in place of macros. So, did we just waste our time discussing macros? No. First, you get a really clear understanding of how inline functions work by studying macros, and that's a major reason for all of this. And you get a sense of what it takes to make a code substitution system behave like a function call, in particular, shedding its call-by-name characteristics. And second, there are billions of lines of existing C code, including many of the standard libraries, that use macros, and for that matter, hundreds of thousands of old-fashioned C programmers who still write them. And importantly, C's inline keyword is treated as a suggestion by many C compilers, one they may elect to ignore. In such compilers, if you want to be dead sure of inline implementation, you still need a macro. So, in summary, prefer inline functions when you can, and understand how they work under the hood, but know your macros.